our concerns are these. We have to take the square root of x plus 1. So x plus 1 better be greater than or equal to 0. We have to divide by whatever 3 minus the square root of x plus 1 is. So 3 minus the square root of x plus 1 better not be 0 itself. And we have to take the square root of 100 minus x squared. So 100 minus x squared better be greater than or equal to 0. So if all three are satisfied, then x will be in the domain. And otherwise, there might be a point of discontinuity inside there somewhere. So certainly x would need to be greater than or equal to -1. And what can we say here? Negative square root of x plus 1 better not be -3. The square root of x plus 1 better not be +3. What can you take the square root of and get +3? 9. So x better not be the number you can add 1 to and get 9. Right? 8. X plus 1 better not be 9, so x better not be 8. So there's an issue with x equals 8. We want to explore how the graph may fail to be continuous at 8. What's going on here? 100 minus x squared is greater than or equal to 0. So negative x squared needs to be greater than or equal to -100. Careful here, x squared better be less than or equal to +100 if we divide both sides by negative. So x needs to lie between what numbers in order for its square not to be greater than 100?
It needs to lie between
10 and -10. I'll just take a number. If it's as absolute value less than or equal to 10, when we square it, its square will be less than or equal to 100.
It can be equal to 10 though?
Yes, since it's in the numerator, we square the 10, subtract from 100, get 0, take the square root of 0, but we don't have to divide by the 0. So that's okay. So as far as the domain of this function goes, I just want to get the domain clear in my mind and maybe everybody's mind. And then we'll look and see where the function is continuous. -10 to +10, but x has to be greater than or equal to -1, so that cuts into the numbers that are between -10 and -1. It cuts them off, basically. So we're down to -1 to +10, and then we have to kick out the 8. So it looks like the domain is going to be -1 to +8 union 8 to +10. And I believe it is going to be continuous. I don't think is there a vertical asymptote at -1? What's going on at -1? Well, -1's in the domain. I wouldn't think anything troublesome would happen there. The numerator, nothing awful there. -1 plus 1 is 0 squared is 0, 0. 3 minus that is 3. So it looks like it's fine. It looks like the limit exists. There's going to be a point there at -1. Likewise, at 10 is okay. 10 looks like an x-intercept. That seems like that's going to be fine. But what about at 8? As x gets really close to 8, the denominator gets really close to 0, and the numerator does not get really close to 0. The numerator gets close to whatever 100 minus 8 squared is. 36. So the square root of 36. So the numerator gets close to 6. So this is going to be a vertical asymptote. H has a vertical asymptote at x equals 8. So not only are we saying this is the domain of this function, this is the set of values where this function is continuous, It's continuous on -1 to 8. It's continuous on 8 to 10. We can include the -1, include the 10, obviously not the 8 in either case because that's a discontinuity. And there's a vertical asymptote at x equals 8.